Previously, we have looked at Bayes' theorem as a probability concerning two events. Actually, Bayes' theorem can be extended to any k number of events. Suppose that a sample space is partitioned into k subsets f sub 1, f sub 2, f sub 3 up until f sub k, such that the probability of f sub I is not equal to 0. I equal to 1, 2, 3 until k. This means that the sample space is subdivided into k subsets. F sub 1, this is the first subset, the second subset, and the kth subset, such that the probability of the subset happening is not equal to 0. And let E be an event such that the probability of E happening is greater than 0 as well. Then, the probability of f sub I, any of these events happening, given that E has happened, would be the probability of f sub I times the probability of E given f sub I all over the probability of f sub 1 plus times the probability of E given f sub 1 has happened plus the probability of f sub 2 given probability of f sub 2 times the probability of E given f sub 2 happens plus until the probability of f sub k happening, the last subset, times the probability of E happening given f sub k happens. So, this long formula is actually just saying that Bayes' theorem doesn't work with two events. It can actually work with three or more events. Our illustration and our formula. To show, let's have an example. In the music store, 50% of the CDs are pop music, 35% are jazz music, and 15% are country music. The store owner knows that 5% of the pop music CDs are defective, 7% of the jazz music CDs are defective, and 3% of the country music CDs are defective. A customer returns a defective music. What is the probability that the CD is a jazz music CD? Now, try to see if you'll be able to extend the Bayes' theorem that we've been using for two events for this problem. Alright, so the first thing that we know is that we have three events. The CD is pop, jazz, and country. So if we're going to have our sample space again, it might look like this. There you go. And we can just a little bit. There you go. Center it a little bit. Alright. Then we know that 50% of the CDs are pop music. So I will place a division here, which is a representation already of 50%. So let's write that. This is 50% for pop, symbolized by event P. Then 35% are jazz music. So let's symbolize that division as well. I'm going to have that blue, the blue line. Here you go. It's not supposed to be half, so probably let's move it a little bit here. There you go. Just a good representation. So the probability that the CD is jazz music is 35%. Well, the remaining probability here is the probability that the CD is country. So, C for country, 15%. Now, the store owner knows that 5% of the pop music CDs are defective. That meant that the 5% of this is defective. So, to find that 5%, maybe I can underline it just like this because anyway, it's just small. So the defective ones would be that 5% defective of our 50%, which is actually equal to 2.5%. So let's have that 2.5%. Then, for jazz music, 7% of that. So let's have that a little bit here. There you go. So the defective ones in jazz music would be 7% of the 35%. 7% of the 35%. And that will actually be equal to 2.45%. So let's have that. 2.45%. Finally, 3% of the country music are defective. So, if we're going to have 3%, a bit lower, just like this one here, probably. There you go. And then, to know the defective ones, we're going to have 3% of the 15%. 3% of the 15%. And that will give us 0.45%. Let's write that down. 0.45%. Now, what we want to know is the probability that the returned CD, which is defective, is a jazz music. So, if we're going to write that down here below, what is the probability that the returned CD is a jazz music? Maybe I should have used a different color. The probability that the returned CD is jazz music given it is defective. So based on our illustration, this is what we would like to have. The probability that the CD is defective and jazz music is 2.45%. 2.45% all over the total. And now it's not just 2, but there's actually a 3 because, well, there are 3 subsets that will compose the set of defective CD. So that will be your 2.5% plus your 2.45% plus your 0.45%. This will be equal to 49 over 108 in fraction, or in decimal form, 45.37%. So there's a 45.37% chance that the returned CD is a jazz music CD. So here, we have illustrated that through our visual solution, we can extend Bayes' theorem. Now, if we apply our formula, we have it here. We know that based on Bayes' theorem, the probability that the CD return is jazz, given that it's defective, is equal to, based on the formula, the probability that the CD is jazz, multiplied by the probability that the CD is defective, given it is a jazz CD, all over the probability, the probability of jazz music multiplied by the probability that it's defective given it's jazz music, plus the probability that the CD is pop music multiplied by the probability that the CD is defective given it is pop music, and finally the probability that it is country music multiplied by the probability that it's defective given its country. Oops, wrong color. Probability it's defective given its country music. So there. And we already have these values here, which would just be equal to the one on top, this one, 5% multiplied by 50%. Oops, sorry, not that one, but this one instead, rather. Our 35% rather, that's our probability that it's jazz music, multiplied by the 7% chance that it's defective given it's jazz music, all over this same number, 35% multiplied to 7%, add that to the probability that it's pop music, this number here now, that 50% multiplied to 5%, there you go, plus this number now, that 15% multiplied to 3%. And this will still give you this number. This shows that Bayes' theorem can be extended to more than 2 events.